So hello friends, now we have to start with electromagnetic induction first part, in which we should start with defining electromagnetic induction. What is that? At a basic 10th level, we used to say that due to changing magnetic field, phenomenon of appearance of induced EMF, thereby induced current in a closed circuit, was EMI. But now we'll introduce new term that is called magnetic flux. So after discussing this definition of electromagnetic induction, we are to discuss a bit of magnetic flux also. So firstly, EMI definition: change in magnetic flux, electromagnetic induction due to change in magnetic flux. And this is here. Firstly, we'll be discussing magnetic flux, which is denoted by phi B. It is total number of magnetic field lines passing across any area normally. Mathematically, is B dot A. It is similar to electrostatics, electric flux, but here obviously SI unit would be changed. Weber is equal to Tesla meter square. That means SI unit for measuring flux is Weber. And one more point, 1 Weber is 10 raised to 8 Maxwell. You must have got this idea that Maxwell is CGS unit. Now I'm to enter into Faraday's experiment. Actually, Faraday's performed few experiments, and from those analysis, he could conclude few things. And that conclusion we are to study along with, finally, Faraday's laws of electromagnetic induction. Now I am to give another heading, namely experiments of Faraday's and Henry. Experiment 1. So in this experiment, what do we observe here? We observe that North Pole is approaching towards this coil, having one galvanometer connected. Then current will be induced in the coil in such a way that it will try to oppose this approaching North Pole. So for that purpose, it will have to generate North Pole, and for North Pole, it will have to have anti-clockwise current. So let's see, this is anti-clockwise current it has generated. That means induced current is appearing in the form of anti-clockwise current, and hence galvanometer will show deflection like this, like this. Then afterwards, so in further few minutes, we are to discuss electromagnetic induction in terms of opposing tendency. Wherever induced current or induced EMF will be appearing, that means it will have tendency to oppose the change. That means every change has to be opposed by induced current and induced EMF. And remember, here in the diagram which we discussed, if magnet became stationary, then there would be no induced current. That means induced current will be disappeared at once, because after acquiring stationary position of magnet, there would be no change in flux in the surrounding coil. And remember, first and primary cause of induced EMF or induced current is change in flux. And if change in flux stops, then induced current at once disappears. Then afterwards, experiment 2. Here, I want to write conclusion. Relative motion between the coil and magnet is responsible for generation. That means induction current in the coil. From these words, we can conclude more that there is some relative relation between this magnet and the coil where induced current is generated. Because of this relative movement only, here induced current is generated. Obviously, in coming points, we will be discussing that also. That relative speed is also the factor. That means if this will be approaching more speedily towards the coil, then induced current magnitude will be more also. Okay. So basically, this magical current appears. Why it is appearing without touching anything? Here, nothing happens but law of conservation of energy only. Mechanical energy is being transformed into electrical energy here. So this was carrying mechanical energy with which it was approaching mechanical, that means potential energy plus kinetic energy. Now here electrical energy it is transformed into. So it is no magical thing. Now experiment 2. Now in what we observe in this diagram, that in right part there was approaching magnet in which we saw approaching north pole. But now here that approaching magnet is replaced by a coil. This time magnet is replaced by approaching coil, and in which battery operated current is present. And because of this battery operated current coil, which is approaching towards this coil having only galvanometer connected in that. Here, what do we observe? In this battery operated current coil, the end which is nearer to the coil having galvanometer has anti-clockwise current, that means north pole again, and effectively north pole is approaching. So again in the same way, same story, approaching north pole, this coil will be trying to repel. In order to repel, it will have to generate north pole. For that, it will have to generate anti-clockwise current. And this way, this way, this way, and this way. Relative motion between the two coils is responsible for inducing electric current. Now, here comes experiment number 3. Here the coil C2 carrying current behaves as a bar magnet. One more conclusion from these two experiments. From above two experiments, another conclusion was made that faster the relative motion. Just few minutes ago, I discussed this point. Faster the relative motion between the magnet and the coil, greater is the rate of change of magnetic flux linked with the coil, and larger is the induced current set up in the coil. Then experiment number 3, So here we go. For experiment number 3, what we have this time again, coil C1, like previous cases, again it has a galvanometer connected, and in nearby surrounding in coil C2, this time neither C2 is approaching towards the coil C1 nor it is going away. Then what is new? Obviously, you can see in coil C2, it is battery is connected, but observe switch key K is open. That means it is unpressed. And because of which there is no current in C2. That's why there is no change in flux. That means there is no induced current in coil C1. That's why galvanometer is showing no deflection. That's all. But what do we mention for this? But when the key is closed, the galvanometer records a momentary deflection. After closing the for a long time, there is no deflection. There is no deflection. When the key is open, there is again a momentary deflection, but in the opposite direction. The deflection increases. The deflection increases by many folds when an iron rod is inserted into the coils along their axis. Hence, these experiments are over. Then here comes. So I wanted to discuss one more, and here comes Faraday's laws of electromagnetic induction. Electromagnetic induction. So first law, it is basically definition of Faraday's law, or basically it is definition of electromagnetic induction. Whenever the magnetic flux linked with a closed circuit changes an EMF, and hence current is induced in it, which lasts so long as the change in flux is taking place. This phenomenon is called electromagnetic induction. Now I am to underline few key words and phrases which lasts so long as the change in flux. That means induced current will be appearing until the change in flux keep taking place. At the instant when flux change stops, then and there only induced current will disappear. Okay, here comes second law. This second law talks about magnitude of induced EMF. The magnitude of the induced EMF is equal to the rate of change of magnetic flux linked with the closed circuit. E is equal to the negative sign indicates the direction of induced EMF as opposing tendency. Then for a coil of n turns, E is equal to minus n d phi b. In fact, it is d phi b. This is induced EMF, number of turns, rate of change of magnetic flux. Hence, dimensionally, I'm talking about this is volt is equal to Weber per second. Now, as far as this equation is concerned, this negative sign signify opposing tendency we have mentioned. And this same opposing tendency is talked about in the Lenz's law. Now let's see what is Lenz's law. Slowly we are about to reach final point for this video, for this session, because we are to cover Lenz's law and law of conservation of energy, how it is in accordance with. And numerically, another format also willing to mention, E is minus phi 2 minus phi 1 upon T2 minus T1. Of course, in some cases, we may not have variable expression, Lenz's law and conservation of energy. For this, I'll mention only one liner statement. The polarity of induced EMF is such that it tends to produce current which opposes the change in magnetic flux that reduced it. That means EMF is induced in such a way that it opposes the cause of production of induced EMF. ठेठ भाषा में बोली जाए तो जिस थाली में ये खाते हैं उसमें ही छेद करते हैं. And all the time, in all the cases of induced EMF, we keep observing. They start opposing the origin through which they appeared from. And one more point, the negative sign in the expression for flux in Faraday's represents this effect. Now, lastly, how this law is in accordance with law of conservation of energy. For this, I wanted to paste one screenshot, one question of board's previous year PYQ. Here comes. Now in last points, we were to discuss how Lenz's law is in accordance with the law of conservation of energy. Let's see. Suppose this north pole is approaching towards the coil. Then in order to repel this approaching north, it will try to generate north pole, and for this it will have to generate anti-clockwise current. And in another situation, suppose now this time north pole is going away from the coil, then the coil will induce current in such a way that it will try to attract this north pole which is going away. Then for that it will have to generate south pole, and for south pole clockwise current should be there. So what we saw in each case, whenever there is relative motion between coil and the magnet, a force begins to act which opposes the relative motion. Therefore, for maintaining the relative motion, a mechanical work has to be done, and this work appears in the form of electric energy of coil. That means Lenz's law is in accordance with the principle of conservation of energy. So you can go through this whole answer and take a screenshot also, because this is very important question for board's point of view. So hence this was the first part in the lecture series of electromagnetic induction. Possibly in next video we are to cover, it was methods of induced EMF. So until then, see you, take care, bye.